If we're going to assign a shape to a molecule, we should be drawing it first. Take a moment and see if you can draw this molecule and then make a prediction as to what its shape is going to be. Keep in mind that we're going to be counting the total number of domains. So we look at the total number of bonding domains versus non-bonding domains to make a determination as to what the shape of the molecule is. So pause the video, draw the molecule, and we'll assign the shape together. Sulfur hexafluoride has 1, 2, 3, 4, 5, 6 bonding domains, so therefore it is octahedral. What about bromine trifluoride? Again, we have to draw the Lewis structure to be able to make a prediction about its molecular geometry. So take a moment, draw the Lewis structure first, and then try to assign its correct shape. Bromine trifluoride has 3 bonding domains, 2 non-bonding domains. That's 5 total domains. So we're starting within the trigonal bipyramidal base electron pair geometry. However, 2 of those sides of the equatorial triangle have been removed. So therefore, this molecule is going to be T-shaped. Bond angles that are slightly less than 90 degrees because of those extra pairs of electrons pushing on the overall molecule. What are the approximate bond angles in methane? Methane is tetrahedral, 4 bonding domains, therefore its bond angle is 109.5 degrees. In formic acid, is the C connected to both O's bond angle different than the COH bond angle? Justify your answer. Again, this is going to take some construction of a Lewis structure. So do that first, and then see if you can answer this follow-up question. When I draw the Lewis structure for this, it is a carboxylic acid. This carbon is locked together in a trigonal planar arrangement. This extra bond on this side of the molecule will make this bond angle slightly less than 120 degrees, but for all intents and purposes, this bond angle would be close to 120 degrees. The oxygen that's on the other side of the molecule is bent. So it's actually going to have a bond angle of 109.5 degrees. In complex molecules, we still have the ability to look at bonds to be able to make predictions about the overall geometry. So for instance, I look at this O, and this is a skeletal structure. I know that this oxygen is missing pairs of electrons. I can look at that and I can tell you that it's going to be bent. I can look at this carbon. It's connected to 3 bonding domains, trigonal planar. I look at that nitrogen. It has 2 hydrogens that are connected to it, in addition to 2 other bonds. That would be tetrahedral. So depending on what atom we're looking at in a complex molecule, you should be able to call out what shape that atom has as a central atom. You should be able to also predict the overall bond angle of an isolated atom within a complex molecule. Moving forward, we're going to use the shape of molecules to make predictions about the polarity of the entire 3-dimensional molecule.